So let's start with the assignment 2, and the difference between the assignment 2 and assignment 1 is that a delay has been added in the forward path of this transfer function. Now we need to simulate that model, and the task is again to draw the graph between the error as well as derivative of that error, so that we can find the effect of this delay in the system. So let's start with the SIMULINK model. We are utilizing the same model we had created for the assignment 1, and only the change is I have added the transport delay in the forward path. Double clicking this, I have added the value of the delay 0.4 here. Paddage order, if you want, make it 1 or keep it as it is 0. And then if I check this E dot, it is in the time series format as well as E also. And for the XY graph parameters, these parameters are set as it is what we have set for the assignment 1. Now once we simulate, we can see the XY plot, and this XY plot, I cannot see the complete plot here due to the excess setting of the first problem. First, going back to the MATLAB command window, I wanted to see plot E. Please do remember it is a time series plot. What I wanted to show you here is that this is, see the magnitude of x-axis, it is 0.4. So that means the 0.4 delay is reflected in this E plot or error plot. Now if we check the E dot plot, that is the same observation, again check. So it says clearly the x-axis magnitude is 0.4. And another extra information what we can see is that as compared to the assignment 1, the response is now oscillatory. Moving back to the SIMULINK model, wanted to set this as array, apply, OK, array, apply, OK, and I would like to squeeze the data also to check the plot of error versus error dot, so that I can set the x-axis limit and y-axis limit as per this graph, and double clicking this so I can see the x-axis graph, x-axis limit is x mean is 0, x max is 1, y mean is -8, and y max is 6. So apply, OK, close the graph. So if we simulate again, we can see this is the error plot. Now for figure 2, I have to plot the error dot, I have to plot the error dot, and figure 3 I have to plot E versus E dot. So this is figure 3, figure 1 and figure 2. Now this is the error plot, this is the error dot plot. As I have stated earlier also, the difference with the assignment 1 and the assignment 2 is that the response has become more oscillatory in nature. Now if we have to comment on the system stability, we can say the system is stable. How we can say that? You may argue that still that is the oscillatory response we can observe. So our suggestion is, if we increase the simulation time, we may see that has settled to a steady value. Now again, initial value, starting value 1. For the E dot it is the 0. The plot is started from 1 0. For this oscillatory nature, you can see lots of spiral shape here, and then that is the final value. We have the same value as this error and error plot has. So as you can see that the transient response is reflected in a phase plane plot. So if I see this kind of nature in the phase plane plot, we can say the system has a oscillatory nature, but the oscillation is decreasing with respect to time. That's all for the assignment 2.